Welcome to Pomodoro Joe for Thursday, May 4th, 2023. Today we're doing LeetCode problem. Let's see what we got. 649, Dota 2 Senate. This is a medium problem. Interesting. So this is about Dota. So in the world of Dota 2, there are two parties, the Radiant and the Dire. The Dota 2 Senate consists of senators coming from two parties. Now the Senate wants to decide on a change to the Dota 2 game. The voting of this change is a round-based procedure. In each round, each senator can exercise one of two rights. 1. Ban one senator's right. A senator can make another senator lose all of their rights in this and all the following rounds. Or 2. Announce the victory. If this senator found the senators who still have rights to vote are all from the same party, they can announce the victory and decide to make this change in the game. Given a string, Senate, representing each senator's party, the character R and D represent the Radiant party and the Dire party. If there are n senators, the size of the given string will be n. Okay, the round-based procedure starts from the first senator to the last senator in the given order. This procedure will last until the end of voting. All the senators who have lost their rights will be skipped during the procedure. Suppose every senator is smart enough and will play the best strategy for their own party. Predict which party will finally announce the victory and change the Dota 2 game. The output should be Radiant or Dire. Alright, so the basics of this one are we have this Senate string, which is a series of R's or D's representing a senator from the R party or the D party. Now, we're starting from the left and we're going to the right. They've got some examples here, but let's just take this second one. All right, so if we have something like this, and we're starting from the left and we're going to the right, so the first senator to vote will be this R senator here. And they will naturally cancel out the next non-partied, non-affiliated senator. So this R will cancel out the very first D. They could cancel out the later D, but that would give this first D a chance to actually cancel out some other senator in the R party. So I think the key insight here is you always want to cancel out the first available senator or the next non-canceled senator. Yeah, so you always want to cancel out or ban the next non-banned senator in the list of the opposite party. So this R will vote and ban this D. Then this D gets to vote. Well, what are they going to do? Well, the only thing they can do really is cancel out this R. So they will vote to cancel out this R. So then this R gets canceled. And then the only one left is this final D. So in this one, the D should win. Let's see if that's right. And that is right. Dire. Okay, so a little bit tricky, mostly because this D here, this second D, will be canceling out this R that's behind it. So I guess that's the second key insight. So the first key insight is you always want to cancel the first non-banned senator to your right that is of the opposite party. That will deny them the chance to ban one of your senators. The next sort of key insight here is this wraps. So if you get to the end of this Senate, then the next Senate will be essentially a smaller version of this Senate, but it's wrapped around so that this D, even though it's at the end here, it kind of gets the first vote to ban this R that's behind it. Let's see if I can find a better way to put that. Okay, let's put it this way. So in the first round of voting, you have RDD. So this R gets to go first, and they will ban this D. So this D doesn't get to go. Then we move on to this D, but they are banned, and finally we get to this D. Now this D is actually going to be looking back. There is no senator forward that they can ban. So what we could do, though, is as soon as this guy votes, we could wrap him around to this side, because this guy will be voting in the next round, but only after this guy votes in the first round. So you can kind of think of there's like a round separator here. but we'll just wrap all these still active senators around to the end of our list so that these guys down here, when they vote, they don't have to look backwards. They can just look forward to the next round to find the next senator in the list that they would want to ban. So that's kind of the key insight here, is this wrapping of rounds. So you'll want to, I guess, as soon as one senator votes, you want to wrap them around to the next round so that later senators in this round can ban them from voting in the second round. Okay, let's see if I can explain this a little bit better in practice here. All right, well, let's see, we'll put 25 minutes on the Pomodoro timer and we will get started. So the first thing I'll do is have a result. And I don't know what it is yet, so I'm just gonna set it to none. At the very end, we'll return this result. Let's see, actually. We'll make result D or R, so we'll return dir if result is equal to D, else we'll return radiant. Okay. So now we have our return value. Now this one's going to be a little bit weird. I'll try to walk it through maybe the more complex coding, but more conceptually easy way first. And then we can get to a simpler coding and hopefully it'll make sense once we get to that second step. Okay, so I'm going to start with, we have our current Senate. So, and that's just going to be the Senate. So this is our current Senate. Now we're going to go through our current Senate, check for senators that are active, and they may or may not be moved on to the next Senate. So this is sort of the current round. Maybe I'll call it current round. No, I'll call it current Senate. So we have our current Senate. Then we'll also have a next Senate, and we'll have a stack, for lack of a better word. So these are the pieces that we're going to need. So our current Senate, our next Senate, and then our stack. Now the stack are going to be people or senators that we don't know yet where they're going to go. Okay. So now here we'll just say for every senator S in our current Senate. Okay, so for this we're going to go through, for each senator in our current Senate, we're just going to keep track of how many senators from each party we have and where they are in our list. So when we get to our first senator, we don't really know what's going to happen with the senator yet. So we're going to put them on our stack. Okay, but then when we get to a senator that's not matching a senator on our stack, then those two will cancel out. So you can think of this as, okay, we have a senator, we don't really know what we're going to do with them yet, so we'll put them on the stack. When we run into a senator of the opposite party, then these two will cancel out. But the senator on the stack came first, so they don't get banned. They use their vote to ban the senator that we're currently evaluating. That one gets thrown out. The senator on the stack can then be moved on to the next Senate. They've done their vote and they're moved into the next round. Okay, so we put our senator on the stack, but now if we have a stack and the stack has a senator at the top of the stack that doesn't equal this senator, well, in that case, we're going to ignore this senator. Basically, we've come across a different senator from a different party earlier in our list. Their vote is going to go to cancel out this senator, so this S. So in this case, we can throw out this S, but now this senator will have to be popped off the stack because we've used their vote. They're no longer allowed to vote. So the stack is like pending votes. You can think of it that way. All right, so each one of these senators on the stack is pending their vote. So we'll push someone onto the stack. If we end up with a stack and that stack doesn't match this current senator, then they're going to use their vote. This senator on the stack will use their vote to cancel out this senator. But then we need to move that senator on the stack into the next Senate. They've used their vote, they can't vote again, so they need to be popped off the stack. So we'll have this next senator will be stack.pop at -1. and then we'll move them into the next Senate. Okay, so this is how we can handle, I guess, the case where we have somebody on the stack and they don't match this current party. So that means we don't want to do this every time. We only want to put somebody on the stack if we either don't have any stack at all, or if they already matched the party on the stack. So we can put this in an else here. Okay, so this is a little bit cleaner. Okay, so we'll go through every senator. We'll check to see if there's any senators on the stack waiting to vote. And if there are, if they don't match this current senator, well then that senator on the stack waiting to vote will cast their vote to ban this senator, so we throw them away. Then that senator that just voted to ban this senator, they get moved on to the next Senate. Otherwise, if the stack has people from my same party, or if there is no stack, then this senator gets pushed onto the stack so that they can vote in a future, I guess, when we run across a future senator. Okay, so this handles this current Senate. But this current Senate isn't the only Senate we need to deal with. We need to deal with the next round after we go through all of these. So we're going to need a bigger loop outside of this loop. This only takes care of one round of voting. Okay, so then how do we take care of the other rounds of voting? Well, this is kind of hacky, but this is the best solution I can think of to use in this example. We're just going to have some done. And we're going to set it to false. Are we done counting votes? So we're just going to say, well, we're not done. Then we'll keep going through all of this. So this is one round of voting. Okay, so while we're not done voting, we'll keep going through counting all these votes, canceling out senators, etc. Now at some point, our next Senate will become our current Senate. So basically we run out of our current Senate senators. Now we need to essentially make our next Senate become our current Senate. So our next Senate will have all of these senators that cast their vote. They've already voted, they're moving on to the next Senate. But there might be a bunch of senators on the stack that never even cast a vote because they didn't need to. Basically, these are all the senators from this round that didn't have any future senators in this round in which they wanted to ban. However, we do want to use these senators. They do want to cast a vote to ban people that came before them. So this is where that wrapping that I talked about earlier comes into play. So we can take all of these senators that haven't voted yet, that are in the stack, and we can essentially put them first in the next, quote, round of voting. So they actually get to vote on senators that are behind them, but those senators are getting moved in front of them, if that makes sense. So at this point, if we have a stack, we'll push that first. So our current Senate actually becomes these stack voters first, because they never really got their chance to vote in the last round. So they get to go first in this round. And then we'll append the next Senate to that. Okay, I know this is a little bit confusing, but this is the best way I thought of to explain it. Now we still need a couple things here. So we've got the basics of this. We're going through, we're canceling out senators, we're moving senators on to the next Senate. Then at the end, we're going to create a new current Senate. But when do we end? Because we do need to end at some point. This done has to become true at some point. So there are a couple things we could do. One is we could just say, well, with our current Senate, are they all from the same party? So we could do another loop here that just goes through and says, are all these senators in the same party? That's possible, but it's going to be inefficient. So let's do something different here. So one thing, when we come into this loop, we're going to move these guys in. We're going to start this loop with a clean slate. So our next Senate and our stack here are going to be empty. Then we'll build them up here. Now we only need to go on if we put somebody in our current Senate that doesn't match the other senators in the current Senate. I'm trying to think of a good way to explain this, but it's a little bit tricky. Okay. We only need to continue our loop if we find that we have senators that don't match in our next Senate. So we have essentially senators from both parties in the next Senate. So we can start out our loop by just saying, let's assume we're done. So we're going to assume that we're done, but only if we end up putting senators from both parties in the next Senate are we going to continue. Well, that kind of comes down to this. We check our stack. Well, we know our stack will always be the same group of senators. The stack will always just have one party or the other. It's this next Senate that could have a mix of parties. So let's see here. When we have this next Senate, we can just check. So we're putting something in the next Senate. So if we have the next Senate at index 0, so that's the first element in this first senator in this next Senate. We know there's going to be one because we've appended one here. Well, if that doesn't equal this senator that we're appending, they're from different parties, then we're not done. So we can say done equals false. Okay. The other thing is we still might not be done. This might only have all the same senators. The next Senate might always be D's or R's, but our stack, these ones that didn't get to vote yet, they might be from a differing party. So we better check in here if our stack doesn't match our next Senate. So one thing we can do is say, let's see. So if we had some stack and we had some next Senate, all right, and our stack at index 0, it doesn't really matter, it could be any of them, does not equal our next Senate at index 0, then we're not done. Okay, this one is getting confusing. This is actually more confusing than I thought it was going to be. Finally down here, we actually need to give our result. So what is our result here? So our result will be, well, whatever our current Senate is at index 0. Okay, oh man, so this is more confusing than I was expecting. We're gonna have a current Senate. While we're not done with our votes, we're gonna have a next Senate and a stack. So the stack is not voted yet senators. All right, so then for every senator in our current Senate, if we have senators waiting to vote in our stack, and if that senator in the stack doesn't match this current senator, then they're going to vote to ban this senator. Their vote is used up, so they're popped off the stack. Then they're pushed into the next Senate, so they get to vote in the next Senate, maybe. All right, and then if we don't have all the same type of senator in the next Senate, then we're not done. We have to keep going. All right, if we don't have any senators waiting to vote, then this senator gets put on the stack, waiting to cast their vote. Okay, now at the very end, our current Senate becomes the senators who didn't get the vote yet in this round, plus the next round of the Senate. And again, we have to do some checks here. Were any of the senators in this round, do they not match senators in the next round? If that's the case, then we're not done. At the very end, we just check to see which party's left in our current Senate. And then we return our answer. Oh man, this is really confusing. And we don't pass. Oh, because I spelled radiant wrong. All right, try this one more time. Radiant. Okay, it works. Let's see if we can pass all of the runtime checks. And we pass. And we beat 81% for runtime and 5% for memory. So we pass and we do okay for runtime. Now I'll show you a better, cleaner way to do this. So let's just start this whole thing over. I'll keep the return down here. Okay. So we've already determined that as we go through, we're gathering senators that haven't voted yet. The ones that haven't voted yet are stored in, I guess we hold on to them, waiting for their vote. Once they vote, they get moved to the end of the list. If they vote, they can ban somebody from the other party, and that senator basically gets tossed out. So we can accomplish the same thing by just keeping track of the senators and their indices in our Senate. So the index defines when they get to vote. So let's do something a little bit different. We'll have our R indices, and that's just going to be an empty list. And we'll have our D indices, and that's also going to be an empty list. Okay, then for every index and senator in our enumerated Senate, so now we're just going to keep track of the indices of all the R senators and the D senators. All right, so for every index and senator in our enumerated Senate, we're going to store all the indexes or indices of the R's in our R indices, and we'll store all the indexes or indices of the D's in our D indices. So this is just going to tell us where in our list of senators these different senators lie. So now we have these lists of senators indices. So while we still have both lists, while there's still some senators in each list, we'll go through them. So wow. I'll just copy and paste here. All right, so while we still have some senators in each party, we'll pop one out. So this should be the first one we run across in our list. So let's see, I'll call this one just R. Now we have to pop at index 0. So we're going to pop the one off the front. All right, so we have an R and a D. So this will be the index of the first R senator and the index of the first D senator. Now the first one will be able to cancel out the other first one. So let me rephrase that. So whichever one comes first, they will cancel out the other one. So if the R comes first, so if the index of this R is less than the D, well then they will vote to cancel out that D. And that D will not get to vote ever again. It's gone. So if this R comes before the D, it will vote, it will cancel the D, but then, as I mentioned with the other solution, this guy gets re-queued for the next Senate. So we need to actually push this R back onto our R indices. So we need to append. Now we won't be giving it the same index though. Now at this point we need to give it a future index. So this is where it wraps. So essentially we can take, let's see, we'll get a Senate size. So we will be appending this guy's index plus the Senate size. So we're essentially pushing this to the end of the list. So it's wrapping around. Otherwise, if our D came first, so if our D senator was first, then that D senator will vote out the R senator or ban the R senator, and we'll have to re-queue the D senator on the D indices list. Now at the very end, instead of having this result here, we'll get rid of this result. We don't really need it. We just need to know which one of these lists still has senators in it. So it'll be dire if there's still senators in the D indices list. Otherwise, it will be radiant. So this is our other solution. It's very similar in concept to the first solution, but very different in practice. So we'll go through, grab all the indices of each type of senator, all the R and the D indices. Then while we still have some senators of each kind, of each party, we'll go through, pop a senator out, check to see which one came first. The one that came first gets re-queued and the other one gets banned. All right, let's see how we do. And we pass. Let's see if we can pass all the tests. And we pass all the tests, although we don't do as well. We only get 18% for runtime and 5% for memory. One quick fix we can do here, these are standard lists, but what we could use is a deque, D-E-Q-U-E. So the deque data structure is much better at popping things, pushing and popping things in and out of the queue. So deque stands for double-ended queue, and it'll take the same append method, but this pop 0 becomes pop left. All right, so this should give us a tiny bit of a boost, maybe not a lot. All right, still pass. And we get a decent boost. We're at 62% for runtime and 5% for memory. Our best solution so far was still this first one at 81%. It's a little bit uglier though. Oh, and we are out of time. All right, well, that's it for me. Really quick wrap up here. Our first solution got the best runtime, but it's a little bit clunkier. It's a little bit harder to understand. Our future solution using the deck got a decent runtime at 62%. It's a little bit cleaner. All right, well, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code. Oh, and may the 4th be with you.